Welcome to Geography 485, 585L, Internet Mapping, Module 4.1, Interoperability Standards, WMS, KML, and XML. This week we will be covering three primary topics, starting with the Extensible Markup Language, or XML, and the basic characteristics of that language, as it is a foundation for our understanding of both information related to the Keyhole Markup Language, or KML, and also the service metadata that is provided by the Open Geospatial Consortium Web Map Services. We will then have a discussion of KML itself as an XML document format and as it relates to the representation of spatial data. And we'll finish with a discussion of the Open Geospatial Consortium Web Map Services model in terms of both requests and the responses to those requests, with the key focus being on the core web map service model with the GetCapabilities, GetMap, and GetFeatureInfo requests. Finishing with a brief discussion of the integration of WMS into KML, as both are OGC services, and a part of the KML specification recognizes the capabilities of WMS as one of many sources of map imagery information that can be integrated into the system. So let's start with Extensible Markup Language, or XML. You have already been working with one variation of a markup language in your work with Hypertext Markup Language, or HTML, which is derived from SGML, or Standard Generalized Markup Language. XML is another standard model that is based upon SGML as a structured method of representing content in a flexible and extensible way, but that is based upon a core set of rules that define a valid structure for what an XML document consists of. Both XML and HTML are standards that have come out of the W3C, or World Wide Web Consortium. So while XML defines a general structural model, it is defined in such a way that it allows then application-specific definitions of the content that would be rendered in XML. And this is where the different applications based on XML that we will be working with come in. As you can see in the diagram on the slide, there's a version of HTML based on XML called XHTML, which is also a W3C standard. And you have likely been working with XHTML as you've been developing your web pages, while you might also have been developing them in standard HTML. Either way, there are some similarities between XHTML and HTML, with the primary difference being that XHTML has additional structural requirements because it is based upon XML. Our focus here is actually on the OGC uses of XML, particularly as it relates to KML, or the Keyhole Markup Language, and the XML capabilities files that are delivered by a wide variety of Open Geospatial Consortium standards. And you might recall from last week, I also mentioned GML as a data format standard, also from the Open Geospatial Consortium, which is also based upon the XML standard, using XML as essentially the structural definition of the representation of features consisting of points, lines, and polygons and their associated attributes. XML version 1.0 was released as a W3C recommendation in 1998, and it's currently in its 5th edition that was released in 2008. And as I note on the slide, there is a version 1.1 of XML that was released in 2004, but that actually has not received broad use. And many applications continue to use the most recent version or earlier versions of the XML 1.0 recommendation, with the link provided to the recommendation webpage on the slide. So when XML was being defined, it had a set of design goals that were really founded in an attempt at simplicity, ease of use, and flexible implementation. So as a part of these design goals, you can see some of them here. First, that it should be usable over the internet in a straightforward manner, in that it does not use any unusual encodings or other representations that cannot be easily exchanged over the internet. Also, XML was designed to be able to support a wide variety of applications. So while it has structural requirements, those structural requirements embody a tremendous amount of flexibility in terms of how that structure is used to represent content required for particular applications. Given its lineage from SGML, XML was required to be compatible with the SGML standard as a predecessor. It was also required that it should be easy to write programs that process XML documents. And while some might argue with the ease of writing those programs, XML is a very broadly supported standard in many programming languages. So there are many tools that actually streamline the processing and work with XML documents. The XML standard was really defined with the goal of optional features in terms of features of XML itself that were not required to be implemented by systems that claim to be compliant with the XML standard, with the goal of minimizing those optional features, so that basically that translates into consistency from one platform to another and one application to another in terms of the core XML requirements. Another goal, and again, some might argue with the success in achieving this, but once you're familiar with reading XML, they actually are somewhat human legible, and if well designed, can be reasonably clear to read through. This provides the dual benefit of both being machine readable because they comply with a predefined set of structural requirements, but also being presented in such a way that a person can look at an XML file and be able to understand to some extent its structure and content. Also, as a part of XML, there was a design principle that really aimed for rapid development of specific XML documents. So this gets back to the relative simplicity of the structural requirements and the ease with which those structural requirements can be met in designing XML documents. XML was also defined formally and briefly as a concise design specification, so that again, it is more straightforward to implement and understand. Aligned with the design goal of rapid preparation of XML design, XML documents themselves should also be easy to create, whether you want to use a standard text editor or any of a number of dedicated XML processing and production tools. They should be easy to create. And one other characteristic which has both pros and cons is that terseness in the development of XML markup was of minimal importance. And this is really a part of the trade-off as we're talking about human readability and the rapidity with which documents can be created and with which designs can be created. That tends to lead to verbosity in terms of the XML documents that result from that process. That verbosity translates into what can be very large files, as I mentioned last week, relating to GML documents, as they are easily transportable, but they are very large, so they do often require greater network bandwidth, for example, or storage capacity to be able to transfer and store than other more compact binary representations. With the trade-off of that increased, you might say, bulk of XML documents, the trade-off being the verbosity and readability of those documents for both humans and machines, as the benefit that comes from that verbosity, but at a cost of file size and increased network transfer times. So when we talk about XML structure, we have two core concepts that you need to think about. The first is whether an XML document is well formed, which is essentially a document that conforms to the structural definition of XML. So this is the definition of how the content at the most basic level should be structured, independent of any specific content or content types. So in the case of well-formed XML, it is either well-formed or it is not XML. That is a foundation requirement that any system that is implementing support for XML has to be able to both develop in terms of XML that is being published by that system, but also any systems that are going to be processing XML will typically do an initial check for validity to determine whether or not the document that they're going to be working with is well formed, generating an error if it is not. The second level of XML structure that really relates more to specific applications that are based upon XML and the specific content that is encoded in XML for those applications is the concept of valid XML, which starts with a well-formed document meeting the structural requirements of XML, but then also there is a specific model that is defined using an external specification in a number of different languages, where that specification defines the actual element names that might be used, which elements are required and which ones are optional, what the content of those elements might be in terms of different variable types, different values, how those elements may relate to each other in terms of nesting or relationship. These are all higher level definitions that go beyond the mere assessment of whether or not a document is structurally valid by the XML requirements. But this is essentially a document design specification that can be checked to determine whether or not a particular XML document is consistent with that document design. And the two methods for defining that design are basically the document type definition, or DTD, which was the original specification for how you could define the elements and their ordering in relationship to each other. Or more recently, the introduction of what are called XML schemas, where XML schemas can be defined in a variety of languages. So there's not just one schema language, but there are a number of them that have been developed out there. One of them comes from the W3C. One of them is called Relax NG. Another relates to Schematron, a set of tools for defining XML schemas. There's an ISO schema and others. So the schema documents are the current state of the art for defining what the structure and content of an XML document should be. And it is those schema documents that are referred to by the XML documents that are being exchanged between applications, and is those schema documents that are used by those applications to validate the content of the XML documents that are being used. You can see more information about XML also in the linked Wikipedia article here. So let's now walk through a simple XML document and talk about the various components of that document, highlighting how those components relate to each other in creating a structurally well-formed XML document. So we're going to start with this XML file here, with the source of this file originating actually at an XML tutorial at the W3C Schools website. So the first thing you're going to see in an XML file is some amount of information in the top of the XML file that at the very least is going to include an XML declaration and may include one or more comments related to that document. So you can see here I've highlighted the XML declaration and this comment that is included in the XML. You can place comments anywhere in an XML file, but it's good practice to often include some comments in the Prolog area that talk about the particular characteristics of a particular document. Elements in an XML document essentially define blocks of content generically. Where the root element is a particular type of element within an XML document, first and foremost, it is required. Second, there is only allowed to be one root element. And third, it must be represented by a pair of opening and closing tags. So in our document that we're looking at here, this is the opening element of our root, and this is its corresponding closing element at the end of the document. This is analogous to what you've already been seeing as you've been developing your web applications, where you have the HTML opening tag and the closing HTML tag at the bottom of the web pages you develop. If you're writing your pages in XHTML, that HTML element is the root element for the document that you've been developing. If you have more than one root element, you are not developing a structurally valid XML file. Content elements essentially contain all of the other document content, and they may have paired opening and closing tags, as we just saw with the root element, or they may be self-closing, in that they are essentially a single tag that has a terminal slash at the end of the element before the closing bracket, as you can see here with this example of an XHTML break element, where you have an opening bracket, BR, space / closing bracket. So this is an alternative when you have an element that allows itself to be closed like that, to have a single element as opposed to a pair of opening and closing tags. So in this sample XML document, we have a number of elements. We have this to element that is paired with its closing tag here. We have this from element with its matching closing tag. We have a heading element here. And we have a body element here. And you'll notice that this body element contains an additional piece of information that we'll talk about in just a minute. But basically, the element is defined by the name, and then any additional content that is separated by the name by one or more spaces. So this is still a body element, though it has additional information inside of it. And as a result, it has a corresponding /body closing element on this side. So each of these is a content element as a part of the XML document. This body element also has this name value pair where we have type equals instruction. This is called an XML attribute, and you can add attributes to elements inside the opening tag of those elements. It is valid to include any number of name value pairs in your XML element, but if you're going to be doing validation with a schema or DTD, you have to define those attributes ahead of time. So here we have the attribute name, which is type, and we're setting it equal to a value of instruction. In all instances, the value should be included in quotes. You should never have naked content associated with an attribute. Some elements may have content. Not all elements are required to have content, but some may. So in this case, content is simply the material that is contained between the opening and closing tags of an element. So here, this highlighted text is the content for the to element. This is the content of the from element. The content of the heading element, and the content of the body element. There are some debates within the XML developer community as to whether some content should be defined through attributes that are associated with the elements and embedded within the opening tag of the elements, or whether they should be included as content within the elements. This is a decision you'll need to make as you're designing or working with a particular XML application, but you can potentially put similar information into both attributes and the content area. And that's something that you will encounter as you look at or work with different XML documents. So let's get back to this question of well-formedness versus validity. So in this case, this is a well-formed XML document, but not a valid XML document, simply because this document conforms to the structural requirements of XML, but it makes no reference to any DTD or schema that could be used to validate it. So it's actually not possible to determine whether or not this document is valid based upon the current content of the document or the information that we have about the document. This is a very simple document that we've used in highlighting the different characteristics of a basic XML document so you can have some idea of how to read the content of a document. And there are some additional elements in XML that you may also encounter. First is a document type declaration within the Prolog. So within that, there's actually the specification of a particular DTD within the Prolog that can be included either by reference or actually by injection into the document itself that defines the structure of the document for validation. So here we see an example of one such document type declaration that includes here a reference to a DTD. This DTD could be accessed and used to validate the XML document that this doc type declaration is a part of. Something else that you may see in XML documents are known as C data sections. Because of the structural requirements of XML and the use of some particular characters in defining the structure of an XML document, there are going to be instances where you may need to use those characters as a part of the content of a document as opposed to defining the structure of a document. And a common scenario for that is when you're using bracketed text or brackets in general as a part of the content that is going into your document. The way you can separate or define that content that you want the XML to essentially ignore as far as markup or structure is concerned is to surround it within these CData tags here, which you see. This is the beginning of a CData tag. And then we have the end of that same tag over here. So this is wrapping that entire block of context, which in this case is this greeting hello world / greeting content area, which if you did not embed it in this C data element would actually be interpreted as a greeting element in XML and its associated hello world content, which is not what you want to necessarily do in the context of this example. So this is something that you would essentially be telling XML processors to ignore as a part of the structure of the page, but to only treat it as essentially content. You may also encounter XML namespace declarations, where this is additional information that can be included essentially anywhere in the XML document that defines a prefix that can be used for any elements to distinguish those elements from others that may have the same element name but have a different meaning in the system. What do I mean by that? It's probably easiest to illustrate it from the example that we have here. So we have our root element. So this is the opening tag of our root element for this XML document. And you can see the closing tag down here. I've added 2 XML namespace designations. That's XML, NS:, and then the abbreviation that I want to use. So in this case, I'm using H, and in the second one, I'm using F. And I'm setting those equal to some unique identifier. And the standard in XML is to use something that looks like a Uniform Resource Identifier, or URI. And the best practice is that those URIs point to an actual online resource that provides information about the particular elements or namespace that you're using. But while that is a best practice, it is not a requirement. You could use any URI that you want within these quotes as part of the setting for creating a namespace prefix. So I've created these two namespaces, one called H, one called F, and I'm now going to use them within this root element. So you can see I have this block of content here that looks a lot like an HTML table set of elements, where I've got H:table, and then within that H:TR for table row, and then H:TD for table data, and then closing tags for all of those. Now, if I was developing an XML file that also had a concept of furniture, where you might have attributes of a particular piece of furniture that you want to capture, say a table, I can use separate namespaces to have two elements that have a base name of table, but I could distinguish between them using this namespace prefix. So when I'm talking about this HTML type of table element, I prefix those elements with an H and a colon. When I'm talking about a furniture table element, I precede those elements with an F for furniture. That way, all of my elements, though they might have a common base name like table, are distinct from each other and have any ambiguity about what they mean reduced or eliminated through reference to the namespace. This is something that you will see in more complex XML documents, especially as we're working with the OGC standards, as different standards are brought into an XML file to define the content model for those files. And those namespaces provide an effective means of what's called disambiguating what those element names represent and what they're referring to. So KML is now a geospatial application standard that is based on XML. So it meets the structural requirements of XML, and it has a specifically defined schema that provides the structural and content information that is specific to the appropriate content for a KML document. KML started as the Keyhole markup language by Keyhole Incorporated that they were using in their Keyhole Earth Viewer. When Google acquired Keyhole in 2004, they started evolving KML. And when Google joined the OGC in 2005 and 2006, they brought KML with them and started KML through the OGC standards process. And KML version 2.2 became an official OGC standard in 2008. You're going to encounter KML files in two basic file formats. You're going to first encounter KML files that end with a KML extension, the last three letters of the file name, where those KML files are a simple XML document that is directly readable and editable. You could actually open it up in a text editor or XML application, and you can directly read the contents of that file. But given the verbosity and the potentially large size of KML files and the XML that they're based upon, and also providing a capability to package up a base KML document with associated content such as images or other data, the KMZ variant of KML was also defined as a part of the standard, where a KMZ file simply has a .kmz extension, and it is a compressed archive using the zip algorithm that is broadly supported by many operating systems and tools, that contains at the very least a KML document, but may also contain other files and folders within that compressed archive. If you want to look at the contents of a KMZ file, you would typically either open it up in an application that directly understands the KMZ file format, Google Earth, for example, or you could otherwise decompress that file, which in some cases requires you to change the file name extension from KMZ to zip so that the operating system recognizes it as a zipped archive, for which you can then use whatever tools are on that operating system for opening up and decompressing that zipped archive. So it's typically a two-step process of changing the file name extension and then decompressing it. You can then look at the contents of that KMZ file, which will include at least a KML file. KMZ files are frequently exchanged KML version over the internet, as they are much smaller to transfer over the network. So KML has a number of capabilities. Overall, KML allows you to annotate the earth. So it provides a set of capabilities for defining both location and attributes associated with those locations, and then even representation models for how those locations should be symbolized. So you can, as a part of KML, specify icons and labels to be associated with those locations. You can create different camera positions or perspectives, so you can actually view features defined in KML from different elevations or angles. You can define what are called image overlays that can be attached to either the ground coordinate system within the global reference system in KML, or to fixed coordinates in the whatever viewer application may be providing access to the KML file. So think of the difference of putting a label on a map, and as you move that map, the label moving with it, as opposed to, say, a logo for the source of the KML file that you always want to have appear in the lower left-hand corner of a view window of the software application that is viewing that KML file. You can also define styles that modify the display characteristics of particular features that you've defined in KML. For annotation of objects and providing capabilities analogous to the info windows that you've been working with in Google Maps, you can write HTML descriptions associated with KML features that may include hyperlinks and other embedded images. So essentially, you can treat the HTML descriptions as small blocks of web content that you can link to the features. KML includes the ability to organize hierarchical systems of folders and subfolders for organizing features into groups. KML also allows you to locate update, and retrieve KML documents from either the local file system, so that might be a document that is contained within a KMZ file, or even remote network locations. And that is the key capability in terms of the remote network access that relates to the implementation of the OGC Web Map Service support within KML. And finally, within KML, you can actually define the location and orientation of three-dimensional objects within the KML coordinate system. So it's a three-dimensional coordinate system that you can define three-dimensional objects and their representation within. So the KML content model allows for the encoding of both 2- and 3-dimensional geometries for use in 2-dimensional mappers and also in 3-dimensional virtual globe applications like Google Earth. So you can imagine, in terms of the 2-dimensional mapping capabilities, being able to bring a KML file, say, into ArcGIS or another 2-dimensional GIS application, and being able to display those 2-dimensional geometries within that system. KML uses a core latitude-longitude coordinate system that is based upon the WGS84 datum for encoding horizontal position. So all locations in KML are defined in latitude and longitude WGS84. When adding a third dimension, altitude is represented in meters based upon the WGS84 ellipsoid and the EGM96 geoid. So these are the reference models for expressing altitude in units of meters. So here we have an example of a very simple KML file on the left that, after our introduction to XML, should look fairly familiar. And in this case, the document is contained within this KML root element. We're defining a place mark. Within that, we're defining a polygon, where that polygon then contains a number of elements. First, we're defining the altitude mode of the polygon. Here, saying that we want to essentially clamp that polygon to the ground surface. And then we're defining the outer boundary of that polygon as a linear ring element that ultimately is represented by a set of 5 coordinates, where you'll notice here these coordinates provide a closed polygon with the first and last coordinates being the same, providing the closure. You'll also notice that the format of these coordinates consists of comma-separated values, with the first 2 values, the longitude and latitude, required, the third, the altitude, being optional. So in this case, we have a longitude of -135 degrees, a latitude of 78.5 degrees, and an altitude of 300,000 meters. Those 3 values associated with the first coordinate are separated by commas. All subsequent values are separated from that triple separated by commas by a space or a new line, basically by white space. So you'll see that we have now these other 4 coordinates that, if we look at it in a 2-dimensional grid, is this highlighted area here in a planar representation. And if we project or map that polygon onto a spherical terrain, you can see what it looks like superimposed upon that sphere or elliptical surface. So if we look at that, I can download this file and open it up in Google Earth. We can see basically that polygon that I've defined, which is in basically a rectangle in latitude and longitude coordinates, when draped over the virtual globe, assumes this shape. Any application that supports the KML standard should be able to display this very simple KML document. So some of the content types that you can put into a KML file include features that might actually generically include other documents, folders, place marks, or links to external resources. Geometries that can consist of individual points or line strings, essentially linear features, polygons, three-dimensional models, or what are termed locations within KML. You can define overlays that include ground overlays, where you can essentially define content that should be superimposed over the ground and coordinated with the ground surface, essentially the spatial data units for the data being used. Latitude, longitude boxes, photo overlays so that you can define essentially the extent of a photo and how it corresponds to a location on the ground, or screen overlays where you can essentially locate some content in reference to the display screen as opposed to the coordinate system of the map viewer. You can define name styles, substyles, icons associated with those styles, and styles associated with labeling for text to be displayed within a KML. You can create links within your KML pointing to external resources. You can create views that allow you to control the elevation and orientation of the perspective that users might have in viewing the content of a KML file. And finally, there is some basic support in KML for time, whether it's a particular time span or a particular point in time represented by a time stamp. So if we look at what some of these files look like, we can look at a demonstration here, and also on this page are some links to both the Google Code KML documentation that includes documentation for both the OGC standard and also Google's extensions to the KML standard, which provide some additional capabilities, but you need to be aware that those are not necessarily going to be supported by all the clients that do support the OGC standard. And then a link to the access page as well for the OGC KML implementation specification. So if we first want to take a look at a KMZ file that is coming from the New Mexico Resource Geographic Information System, I can click on this link, which in this case will then download that file to my system. So if I change to my file browser, I'm working on a Mac here, but you would go through a similar process on a Windows machine to access the file that you want to work with. In this case, you can see this is the file that I downloaded, And if I just double click on it, that will open up that KMZ file in Google Earth. If I turn off that previous example that I had opened and zoom out a little bit, because Google Earth tends to put the additional state boundaries and other boundary files in a higher stacking layer than some of the background material, which is treating this as. You can see it's partially obscuring the state boundary for this KMZ file. But if I zoom in just right, you can see it poking out from underneath the gray state boundaries. So the red line in this is the state boundary as it's embedded in this KMZ file. If we go back to this file, and if I change the file extension to .zip and open it, I now have this decompressed folder that is the contents of that KMZ file that I downloaded. And if I double click on that folder, you can see that that contains just one file, a KML file. And I can open that up in an editor. In this case, I'll open it up in text edit. And this is what the KML file looks like for that particular state boundary. So we can see here, here's the prologue essentially of our KML file, defining the KML namespace that we're using, the opening element of our document root, and then the creation of this folder, the opening of this folder that has this particular name, the definition of some attributes and their types. This is actually the schema definition for the content of the attributes for the elements in this. And then we can see here there's a place mark that is being defined with some style information associated with it. The definition of those attributes associated with the polygon, this place mark, and then the polygon itself, which is this set of coordinates, which in this case is just the set of longitude-latitude pairs separated by spaces. And you can see I have this long list of coordinates that represent the shape of the state boundary. Then if I scroll all the way to the bottom, you'll see all the corresponding closing tags for the KML document that we've been working with here. So this is what a living, breathing KML file looks like that you might want to edit or examine. Now let's talk about the Open Geospatial Consortium Web Map Services standard, where the Web Map Services are a standard that really focuses, as we discussed last time, for requesting map images, not map data. And there are three core requests that we're going to talk about here as they relate to the WMS standard. The first and key to gaining an initial understanding of any web map service that is published on the web is the GetCapabilities request, which returns the service metadata about that web map service. And it is that service metadata that is represented as an XML file that provides the information you would need to be able to develop and submit requests to that service. Once you have read the capabilities XML file, or more frequently, once an application that you're using has read that GetCapabilities file, a GetMap request can be developed that will hopefully, if properly composed and submitted, return a map image that is a graphic file representing one or more layers from that web map service, where you are defining as a part of that request, in addition to the layers that you would like, the area of interest in terms of a bounding box, potentially information related to a particular point in time, as WMS does support a time parameter, the format of the image to be returned, and other attributes of that response. And we'll cover those in more detail in just a moment. There's also something that I've often referred to as sort of a poor man's query, where you can use a get feature info request to obtain feature information from a web map service for one or more layers for that service, if those layers are identified as queryable. And those queries are based on a specific pixel location in a map image that would be generated in response to a web map service request. So you could think of a get feature info request as being a request that uses the coordinate system of a map image that is generated by a get map request to define what location you would like information about layers from. So a web map service will return one of these types of objects in response to an incoming request, or it will provide an error message. And those error messages can be key in determining if there are any problems, or if you're not getting a response that you expect. Those error messages are important for being able to identify what problems there might be in a request that's being submitted, whether they're missing parameters, misnamed parameters, or invalid information that's being submitted. So as you're working with web map services, you should always keep in mind those error messages that you're likely to get back as you initially start trying to interact with web map services. There's a related style layer descriptor, or SLD standard from the OGC that provides some additional optional capabilities for web map services for essentially dynamic visualization updating of the map images that are returned. We're not going to talk about SLD here, but it's something that you should be aware of if you start working with web map services in your own day-to-day work. If you see that they support SLD, that's a mechanism that you can use to actually modify the representation used in the map images that are returned to you. So that's a very powerful capability to have some control over the map images that are returned beyond the standard WMS bounding box format time type requests. And finally, there's a link here to the documentation access page for the OGC Web Map Service Standard. So the WMS GetCapabilities request has evolved somewhat from the first version, or version 1.0 of WMS, to the subsequent versions 1.1, 1.1.1, and 1.3. I'm not going to go over these in tremendous detail, but I provide these for reference so that as you're working with the different versions of the WMS standard, because the version support is advertised by the individual web map services that you may be interacting with, knowing that there have been slight changes in terms of which parameters are required and which ones are optional, and what those parameter names and values are, can help you quite a bit in figuring out why some requests may or may not be working. So one thing to keep an eye out for is this as a part of a GetCapabilities request, and this actually carries through the other requests, is in version 1.0, there is this WMT-ver parameter that essentially defined the version of the standard as 1.0.0. In all subsequent versions, you instead use the version parameter and set that to the numeric value of the version that you're wanting to use as your submitted request. While the WMT-ver request was required for 1.0 of the WMS standard, the version parameter is optional for all subsequent versions of the standard. If you don't specify the version number, that will not create an error in 1.1, 1.1.1, or 1.3.0. You are required to specify service equals WMS as one of the parameters for a GetCapabilities request. From version 1 to the subsequent versions, the request type changed, where in 1.0 the request was equal to capabilities. In all the subsequent versions, the request is equal to GetCapabilities. So again, that's something that you're going to have to keep in mind depending on the version that the server that you're working with supports. The request is also a required parameter. You have to provide it as a part of a GetCapabilities request. And finally, you have some an additional update sequence parameter as an optional parameter for the more recent versions, where if a server is supporting some cache controlling and other such capabilities, you can specify a particular update sequence parameter. Finally, for version 1.0, there was support for additional vendor-specific parameters that would only be supported by a particular system that is implementing WMS. The getMap request, as you might expect, is a more complex request and has a much larger set of required request parameters. Those parameters have also changed somewhat with the different versions, and I'll highlight for you here what those changes have been. Starting with whether you're going to need to use WMT-ver equals 1.0.0 for a version 1.0 WMS, or version equals and then the version number for anything since 1.0. This is required, so you'll need to make sure you get that right. The request type also changed after version 1.0, where for 1.0, the request was equal to map. For all subsequent versions, the request was changed to getMap. All versions have had a required layers parameter, where you specify a comma-separated list of layers where you have to provide one or more layer names as a part of that list, where those layer names are determined by an examination of the capabilities XML file that is returned as a result of that capabilities XML request. There's a required styles parameter, where in this case, you can actually leave the right-hand side of this parameter blank. So you can say styles equal blank as a part of your request, and that's a valid request. But you absolutely need to have that styles parameter as a part of your request. Otherwise, you're going to generate an error. There's a note here that if you're working with an SLD-enabled service and you're specifying an SLD parameter, that styles parameter becomes optional, but that's beyond the scope of what we're working with here in terms of essentially the core getMap support. You're required to define the spatial reference system, which, depending upon the version, is either referred to by the parameter name SRS for version 1.0, 1.1, and 1.1.1, or as CRS for version 1.3.0. So this is something else that you'll want to keep in mind as you're submitting different versions of WMS requests. So if you specify version 1.3.0 early as a part of your request, make sure that you're requesting a CRS parameter instead of SRS. Likewise, if you're submitting a 1.0, 1.1, or 1.1.1 version request, make sure that you're submitting an SRS, Spatial Reference System request. You'll see that the format for both of these is the namespace :identifier, where the common approach is to use EPSG as the namespace and then the EPSG numeric code as the identifier. And we'll see an example of that in just a minute. Another required bounding box for all requests for all versions is the bbox parameter, where you basically define the min x, min y, max x, max y bounding box for the map image to be returned, where those coordinates are defined in the units of your spatial reference system. So if your spatial reference system is in latitude and longitude, you'd be providing those min x, min y, max x, max y values in decimal degrees. If your request is in, say, UTM meters, those values would be in UTM meters. That's something that you need to keep in mind, that these units correspond to the units of the spatial reference system that you have defined as a part of the request. Another required parameter is the width parameter, which is the width of the map image that is going to be returned by the server, where that width is defined in pixels. So if you would like a 300 pixel wide map, you would set width equal to 300 here as a part of this parameter. As a complement to the width parameter, there's also a required height parameter, where, as you might expect, you define the height of the map image to be returned in pixels. And we'll have a lab exercise that helps you work through the challenge of making sure that your bounding box corresponds to your width and height properly, so that you don't end up with a warped map image that does not truly represent the vertical and horizontal sort of shape of the objects that are in your map image. And we'll talk about that in terms of aspect ratio and maintaining a consistent aspect ratio between your bounding box and your width and height that are defined as a part of your WMS request. The last required parameter is a format parameter, where you define the format of the map image to be returned, where that might be image/JPEG, image/PNG, image/GIF or GIF, or any other formats that are supported by the Web Map service. How do you find out what those formats are? You read them out of the GetCapabilities XML file that is returned as a result of the GetCapabilities request. One key thing to keep in mind when you're thinking about the file formats that you're requesting are the capabilities of those different file formats for support of transparency, where JPEG is a format that is optimized for imagery, think photography, and it does not support transparency. So if you want to request a map image where the background or areas where there are no data might be rendered as transparent so that you can see through them, you would not want to use JPEG, and instead you might want to use PNG or GIF, both of which do support transparency, or the definition of areas within an image that contain no data that should be rendered as transparent as opposed to opaque. Related to that capability is the optional transparent parameter, where you can set that to either true or false, where the default value is false. So again, if you're trying to request a map image where you do want a transparent background, you would need to both request a file format that supports transparency and specify transparent equals true. If you don't request a transparent format or don't specify transparent to true, you're likely to end up with an opaque map image, which is not necessarily what you're looking for. Also, as a part of this, you can provide an optional background color parameter, BG color, where you can define the background color that should be rendered as transparent. So this is another way to specifically define for the server what background color you would like, or what color you would like to be rendered as transparent. Many servers will take care of that automatically within the definition of their service, but this is an option that you have. The optional exceptions parameter allows you to define what format any error messages that you get should be provided in. So if you'd like them in something other than the default XML format, you can define that here, where the available formats are again provided as a part of the capabilities XML. Starting with version 1.1 of the WMS standard, there was support for the time parameter, where this is an optional capability of the server, and this is also an optional capability or parameter that can be submitted as a request. If the server does not support it, then of course your time request will not be valid. But in cases where the server does support time, you will see the definition of a time dimension in the layer information as a part of the capabilities file, and you can then provide a time parameter as a part of the request to the web map service. This is a very powerful capability for potentially drilling into what may be very large data collections that have repeated observations or even irregular observations through time, where you want to pull out the particular data that represent that particular point in time as opposed to all of the data. There's also support for an elevation dimension, which would be defined as a part of the capabilities of a particular layer in the map service. And you can provide an optional elevation parameter to those services to retrieve data that correspond to a particular elevation. So you could think of a set of atmospheric model outputs, where each layer in the atmosphere may have its own set of data that you want to visualize. You could potentially use this elevation parameter to specify which elevation you would like out of that collection of data. Other dimensions may also be defined in the capabilities file and as a part of the service. And if they are defined for the service, you may also include them as a part of your WMS request. And this is again optional for all versions since 1.1. And then also there is support for vendor-specific parameters that are particular to a given platform that is providing the web map services. The WMS GetFeatureInfo request has also evolved somewhat through time, where, as we've seen previously, there is the change from WMTVER to version, from version 1.0 to the subsequent versions of the web map service standard. The request term also changed, as for 1.0 it's request equals feature info, and for the subsequent versions the request is equal to get feature info. Both of those are required as a part of the request that is submitted to the system. Also required is a set of the get map request parameters that would result in a map image that is the foundation for this get feature info request. So you could think of this map request copy item here as a required collection of get map parameters that you would look at the previous listing to see the values of. In conjunction with that, we then need to define the specific layers that we would like to query. And we do that using the required query layers parameter, where that's just a comma-separated list of the layers that should have values returned for them. The info format parameter is optional until the most recent 1.3.0 version, where it's now required. In terms of the format of the query results to be returned, where those are listed again as a part of the GetCapabilities document for that particular service. You can also limit the number of features for which information is returned, which is useful for bounding what could be a very large set of data to be returned as a part of the query results. So you can define this optional feature count parameter to define the number of features that you would like information about. If you don't provide this value, a default value of 1 will be used. So you'll get information about one feature for each of the layers provided in the query layers list. You're required, as a part of the get feature info request, to specify the coordinates or location within the map image that would be returned as a part of the get map request in pixel dimensions, where in the different version 1.0 or 1.1 or 1.1.1 versions, there is an X and a Y parameter where you define the pixel column and the pixel row that should be used to extract the query results. Those parameters changed with version 1.3.0, where now the parameter names are I and J, where you are again specifying the pixel column and pixel row, but you're actually providing that in the map coordinate system, as opposed to counting from the upper left corner for both of those. Those are required parameters, and you just need to choose the correct one that corresponds to the version of WMS that you've referenced previously as a part of your request. There's an optional capability in 1.1 and onward for specifying an exceptions parameter for being able to get any error that is generated by the service in a variety of supported formats, where the default is XML. And versions through 1.1.1 also had optional support for vendor-specific parameters, with that support being removed from 1.3.0. So what do a couple of these requests look like? We're not going to do a get feature info request. I would leave that to you to experiment with it if you'd like. Here we're going to concentrate on the get capabilities and the get map request. So here in the top of the slide, you can see an example of a get capabilities request where, as you were composing this, you would actually have this entire request on one line without any spaces. I have formatted this, in this case, as showing up on multiple lines so you can more easily see the different parameters and their values as they're defined. But remember, no spaces with all parameters on a single line. If I were to submit this request to some browsers, or in some browsers, just by entering it into the address bar, some browsers will display something like what we're seeing here in the bottom panel, which looks like just a bunch of sort of unstructured text. If you see this as a result of a GetCapabilities request, the good news is that the capabilities document has been returned to your browser, but only that your browser does not know how to display it properly in a more structured form. One thing you can do is you can often right-click and view the source of that page, and then you can see the XML in a more structured form. And so this is what the XML of that particular GetCapabilities request looks like. And you can see some of the common capabilities that we've talked about for other XML document types, where we have up here our Prolog, which includes the XML header, our doc type declaration that points to, in this case, the DTD for the GetCapabilities document, so that if I wanted to validate this capabilities document, I could do so. And that's basically this block right here is that doc type. After the Prolog here, we now have the root of our capabilities document defined here with an additional attribute defining what version of the capabilities XML this particular document is in compliance with. We then have a comment that's been inserted by the server that is supporting this service. And then we have our first content element within the XML document, this service block, which you can see is this entire block right here, where there is the initial useful information about the service as a whole, including the name of the service, which is a more machine-readable name with no spaces in it, a more human-readable title for the service that might be used in clients for displaying information about the service, an abstract for the service that would hopefully provide some additional information about it. In this case, a set of keywords that help to describe the service. And then the base online resource information for the service that is the foundation upon which interactions with this service would be based. And this is your first point of information about how you might compose requests to the service. You'll notice also, as I mentioned earlier, that this is a self-closing element with a slash at the end of it right here. You then have a block of contact information related to the service, so that if you have questions about how the service operates or feedback about the service, there's information about potentially the human being that relates to it, what their position is, whether or not there are phone or fax numbers for them, email addresses. This contact information is useful for being able to get additional information about the service that is otherwise not clear or not available in the capabilities document. And you can see that there's some additional information as well, advertising that there are no fees associated with the service and no access constraints. Those are key to look for if you're considering using a service in your own application or packaging it for use elsewhere. We then have our next block of information, which is essentially the capabilities section that provides the capabilities of the various requests that can be submitted to the system. Starting with the GetCapabilities block here, which is the information about the GetCapabilities request itself. This being here the online resource for being able to submit a GetCapabilities request to that particular service. So this is the base address that you would then add the appropriate GetCapabilities parameters to submit a request to that system. You can see that this GetCapabilities request supports only a single format, this application/vnd.ogc.wms_XML. This is the format that is supported by the GetCapabilities request, which is distinct from the formats that are supported by the other requests that are submitted or that can be submitted to the system. Next, we have the getMap request and the capabilities for that getMap request. How do we know that these are the capabilities for the getMap request? Is that they are in their own block with this opening tag getMap. Within that, we then have a list of the various formats that are supported by the getMap request for the map images that might be returned by this system. So you can see that we actually have 7 different file formats that you can specify as the format parameter for a getMap request. Don't confuse the formats supported here for the getMap request with the formats that are supported by the GetCapabilities request. That is a common error that is made when first reading these GetCapabilities requests, in that this metadata relates to the GetCapabilities request and the formats that are supported, and this block of capabilities describes the getMap request and the formats that are supported by the getMap request. Similarly, you have a base URL here that is provided as a part of the information about the getMap request that would be the foundation for you to build your own getMap request with the appropriate set of getMap request parameters. If we go further down, you can see we have a getFeatureInfo block where there are 2 formats that are supported by the getFeatureInfo. One is text/plain, and the other one is application/vnd.ogc.gml, which would then provide you the query results as a GML file as opposed to just plain ASCII text. And again, as we've seen with the other blocks of information about the request, this is the base URL that you would use as the foundation for formulating a getFeatureInfo request that includes all of the required parameters for a getFeatureInfo request. This particular server also supports SLD, or the Styled Layer Descriptor capability that I described earlier. And that is what these other request types correspond to in terms of additional requests that can be submitted and formats that are supported. Again, don't confuse those with the capabilities for the basic WMS requests that I just talked about. But this is where, if you wanted to start experimenting with SLD, you could get additional information about the SLD specific requests that can also be submitted to this server. We have a block that defines the exception formats that are supported by this particular server. So you can see that there are 3 that you can choose from if you decide to specify what format you would like the errors provided in. There's a block here that actually contains no vendor-specific capabilities, but this is where they could be referenced with this self-closing element. And then there's a final element here that basically documents the support for SLD and some aspects related to that in terms of whether or not users can submit their own symbolization and whether or not there's a way to interact with other remote services to retrieve style information. Again, this is related to the SLD support that we're not focusing on here. We then get to the end of the definition of the support for the various request types and other types of high-level information about the service, and we get to the point where we are now in the area where the layers that are supported by this service are posted. And a common model that you will encounter is a nested layering scheme, where you have a containing layer, in this case, this layer right here, that defines a set of common attributes that are shared by all layers that are within that layer that you're looking at, where you don't have to then repeat those attributes for those other layers. So in this case, we're defining this container layer with a name, which is, again, a name that can be easily be used to refer to by reference in a request with no spaces in it, a more human-readable title, an abstract for that layer, a set of keywords associated with that layer, and a list of supported spatial reference systems and their associated namespaces. So we were talking earlier about when you submit your WMS request for version 1.0, 1.1, and 1.1.1, you would provide an SRS equals, then a namespace, in this case EPSG, colon, and then an identifier, the numerical identifier for that particular SRS. So you would include this entire string, including the colon, in your SRS parameter that you submit to the Web Map service. So you can see that this layer supports this whole list of different EPSG-coded spatial reference systems. You can also see that there is a bounding box specified in latitude and longitude that corresponds to this layer as a whole. This is used by many clients to determine where they should zoom to when initially loading the file. There's also, in some cases, a bounding box in alternative spatial reference systems. In this case, you may see one or more bounding box elements where they define the SRS that the coordinates are provided in, and then the values for the min x, min y, max x, and max y values that are in that particular spatial reference system. All of these values that are part of this layer would potentially be inherited by any layers that are contained within that layer element. And that's the case here, where within that layer element that we've been talking about, we now have this second layer where we have a number of attributes set for that layer, including whether or not it is queryable. So in this case, queryable is set to 0. So a get feature info against this particular layer is being advertised as not being supported. It's advertised as opaque, which is a cue to some clients and how they should try to interact or order this layer. And it's set as cascaded equals 0, which is a cue to some clients that the data for this layer are not coming from someplace else. They're actually natively hosted by the server that is providing the service. Layer names are required to be unique within a web map service. So as a result, there's a name that is specified for this layer. There's a title for this layer. There's an SRS defined for this layer, which is just a single SRS. And then we have 2 bounding boxes defined for this layer, which may actually be different from the bounding boxes that are defined up above for the containing layer. In this case, they're not, but they can be. The other values that are defined within the containing layer are inherited by this layer. And this is all the information that we have about this particular web map service that have been provided by this capabilities document. If you'd like to experiment with viewing this capabilities document yourself, you can click on the live link link that's on this page. The get map request is a more complex request, but fortunately the outcome is a much simpler product, so we can actually go through it more quickly. Where you see on the left examples of 2 get map requests that are quite similar to each other, with the exception of 3 parameters that have been changed. Again, remembering that these are formatted for easy viewing, but as you're composing your own get map request, you should have no spaces, and the entire request should be on a single line of text that you could then copy and paste, say, into your browser window. So here, we're providing the required version parameter, service equals WMS, request equals get map, the bounding box defined in the same coordinate system as the SRS defined right here, where in this case it's EPSG 4326. The list of layers, in this case it's a single layer name. The width and height of the map image that we would like returned in pixel dimensions. The format of the returned image that we would like, in this case we would like it in the format of a JPEG image. And then this blank styles parameter. The image that you see on the right here is the result of that request, which is a 200 by 200 pixel JPEG image that is depicting this single layer as represented within this bounding box. So this is all of the information that you would need to submit a basic get map request for, in this case, a default version of the state boundary for New Mexico. Now let's say, for example, that we wanted to be able to combine this state boundary with other data, and we wanted to be able to superimpose this on background data that we didn't want obscured by the area outside of the state boundary. I can accomplish that by changing 2 parameters. First, by adding a transparent equals true, remembering that transparent is optional and the default value is false if you don't specify it, and changing the format to a image/PNG file, knowing that PNG is a graphic format that supports transparency. Also, I wanted to have a larger version of the image. So in this case, I changed both the width and height to 300 pixels instead of 200 pixels. And you can see on the right here what that combination of changes to that WMS request that I generated have had on how the image is represented on the page here. This is an interesting way you can experiment with these parameters by just essentially generating a base getMap request and then experimenting with different parameters and then requesting the resulting map images and seeing what changes those have on the map image that is returned. Finally, we can bring our discussion about web map services and KML together as we talk about the ability within KML to use the ground overlay element to integrate network accessible images into a client that is reading that KML. And the ability to bring those network accessible images in is then extended to specifically support web map services as map images that you can bring in. So you can treat the URL, the address that we have been talking about here, this get map request, as the source for a map image to bring into a KML ground overlay. And a part of the KML specification actually defines the ability to have the client define the bounding box information and other information that would be dynamically associated with the state of the client. So as a user zooms in and out of a particular window, the client can modify the bounding box information that is submitted as a part of the WMS request. You can also take advantage of the time support in KML to link to multiple time-enabled web map service requests, which in client applications like Google Earth that provide an interface for being able to navigate through time, provide a very powerful tool for being able to view sequential map images associated with data that are published via web map services. So this is a very simple example of the integration of an OGC web map service into a KML file, where we are going to concentrate here on this ground overlay element that I've created, where we're defining a name, in this case, Argus County's web map service. We're defining an icon where essentially we can define an image to be associated with that icon for symbolizing this ground overlay. And if you look closely at this href element, that is a getMap request, with this one change that you need to keep in mind. Again, thinking about the characters that XML tries to use to identify the structure of a document. In this case, all of the ampersands that you would use in a standard URL have been replaced by this string, ampersand AMP semicolon, that is a representation of the ampersand character that can be used to, and is replaced with that ampersand character when that URL is used to request the data. If you instead put ampersands into this string for your web address, that will generate an error and your KML won't work. We've set the view refresh mode to on stop so that the user can move around in the client and not end up generating a new web map service request until they essentially have stopped moving around. And then we've defined a bounding box for this ground overlay that corresponds to essentially the bounding box of the initial area that should be displayed for this KML file. So what does this look like? I can download this KML file and open it up in Google Earth. And once the client stops moving, it's submitting a request to the remote server. And we'll, in just a moment, let me turn off the state boundary here. Where in this case, though I called it Argus County's WMS, it's actually the same WMS for the state boundary. And that concludes our lecture for this week, covering XML, KML, Web Map Services,